Hello and welcome. Today we're continuing with our series on physical chemistry and general chemistry, where we're looking at the first law of thermodynamics. And this is presented to you by Science Visualized. To start with, we'll look at the definition of two terms, scalar quantity and vector quantity. Scalar quantity are quantities that have magnitude, that means size, but no direction. So for example, work, speed, mass are scalar quantities. Vector quantities, on the other hand, contain both magnitude and direction. So an example of that is velocity. So for example, if you say somebody is traveling 30 miles per hour, that's going to be speed, and that's scalar quantity. But if you say that person is traveling 30 miles per hour east, then now you have included direction and becomes a vector quantity. Now let's continue. And let's focus on work. When force is applied through a distance, it results in work. So actually the definition of work equals to force times distance. So work equals to force dot distance or times distance cosine theta. And theta here will be the angle. So for example, if you have a force applied at a certain angle, so you have force there, and then the object ends up traveling in that direction, you have to resolve that force, and therefore you use cosine theta. So we see again, if force is applied upwards, and the distance traveled is s along the x direction or x-axis, then the angle theta is used. And therefore work equals to force times distance, and then you resolve it, cosine theta. Work equals to 0 if you're pushing against a wall. In other words, there is no movement. When there is no movement, then that distance here, s, equals to 0. So force times distance 0 results in 0. So the work will be 0 if no distance is involved. So if you're pushing but nothing is happening, then the work done is 0. You might get tired, but from a science perspective, you're not pushing an object through a distance. Let's continue. Energy is the ability to do work. So energy is related to work, and energy is measured in joules. Both energy and work are measured in joules. Remember, work equals to force times distance, and now energy is the ability to do work. Now, if you consider a small amount of work done, so dW, for an expansion work, so for example, if you have a piston here, and you have a force applied against gas, you have a gas here, then you end up having a change in volume. So that piston can move up or down, resulting in change in volume, and the pressure is applied downwards, or the gas will apply pressure on the piston and push it upwards, and therefore you end up with external pressure. So external pressure is if the piston is applying pressure on the gas. The amount of work done equals to P external, which is external pressure from the surrounding, and delta V is the small change in volume. So we say infinitesimal change of volume. Now the change in volume, delta V, equals to a positive if work is done on the surrounding that means work is being done by the system. So in the example that I just gave, the gas is a system. So if the gas pushes the piston, then you end up with the expansion work, and therefore the change in volume is going to be positive because the system is doing work on the surrounding. So you say work is being done by the system on the surrounding. The change in volume equals to a negative if work is done on the system. So that means you end up with compression. So the gas is compressed. The piston is pressed downwards. And that means the surrounding is working on the system. So work is being done by the surroundings on the system. The change in volume is going to be a negative. Let's continue. So the change in work, delta W, is a small amount of work done to a system. So we're looking at it at a small scale, while just the W by itself is going to be the total amount of work. And remember, it can be work done by the system, and that's going to be positive change in volume, or the work done on the system, and that's going to be negative change in volume. To determine the total amount of work done, we need to integrate. That means we need to consider all the small infinitesimal amount of work over a large volume of changes, over a big volume. So in other words, the total amount of work equals to, remember, minus pre-external times change in volume is the infinitesimal amount of work. So you integrate over the distance. So you put a minus sign outside the integration, and then you just integrate pressure external times change in volume. Now, if this work is being done under constant pressure, so constant pressure, that means P is not changing, P is a constant, then in that case, you move P outside the integral, because if the pressure is constant, then it doesn't vary with volume. So you move it out, and now you can measure the amount of work done, total amount of work done, with respect to change in volume. And when you integrate that, you end up with work equals to minus pressure external times volume, and you're going to look at volume initial to volume final. So in other words, you're going to expand that equals to minus pressure external, which we have here, and then this whole unit there converts to V final minus V initial, and that will be the total change in volume. So in other words, the amount of work, the total amount of work done equals to minus pressure external times the total change of volume. Pressure is measured in PA, which is pascals, or it can also be measured in atmospheres. 1 pascal, 1 PA equals to 1 Newton per meter squared. 1 Newton per meter squared. Work equals to minus P external times the change in volume, and we've said that P external, the unit is 1 Newton per meter squared. So basically you end up with P external, which is 1 Newton per meter squared, times change in volume, which, and we know volume is measured in meters cubed. And when you put those together, you have meters cubed over meters squared. So you end up canceling that, and you just end up with meter. So it becomes Newton meter, which is joule. And there we get a definition of joule. 1 joule equals to 1 Newton meter. Now we'll continue with this. I'll make another video for part 2 of this particular handout. Thank you very much for your time. Please support the channel by subscribing.